For homework problem 1422, we get the same kind of problem, initial rates, finding the rate law. And again, here we've got a reaction BF3 plus NH3 forms F3B and H3. Okay, this is the data. There happen to be 5 experiments. It's very unlikely that you would ever have to use all of them. And there's a small typo down here. This one should be a decimal point in there. So I just added it in. So what's the rate law? First thing we can do is approach this just verbally, because we have what we're looking for, convenient doublings. So if I look at experiments 1 and 2, there I have the BF stays the same while the NH3 doubles. And what happens to my rate? It doubles. Right? So this tells me that it is going to be first order for BF3. Now I can take a look at experiments 4 and 5. Here, 4 and 5, the BF3 is doubling, while the ammonia is staying the same. And again, the rates are doubling. So 4 is twice as concentrated as 5 is, and it goes twice as fast. So it's first order again. So that means my total rate law would be K. Rate equals K times concentration of ammonia times the concentration of BF3. That's boron trifluoride. But we can also do it mathematically. So looking at the BF3, making that same comparison between rates 4 and 5, and substituting in our numbers, we get K can cancel out because it's the same top and bottom, and the ammonia term can cancel out because it's the same top and bottom. So that means that the ratio of the rates is equal to the ratio of the concentrations to the x power. A little bit of math, we see that 2 equals 2 to the x. So x is 1, and the reaction is first order for boron trifluoride, just like we saw by the other method. Then doing the same thing with the ammonia, again, comparing rates 1 and 2. Remember, I always try to pick the rates so that I get whole numbers when I do my division, so I make sure the larger rate is on top and the smaller rate is on bottom. But it'll work even if you don't do it that way. So as usual, the K's cancel out, and this time the boron trifluoride cancels out. So we're left with the ratio of the concentrations of the ammonia to the y power equals the ratio of the reaction rates. And that turns into 2 equals 2 to the y. So y, not x, typo, y equals 1, and the reaction is first order for NH3. This makes the rate law K times concentration of ammonia times the concentration of boron trifluoride. Same result that we got by looking at it and answering it verbally. B asks what's the overall order for this reaction, and it's second order because first order for boron trifluoride plus first order for ammonia gives us second order overall. And remember, this word is what gets you full credit. C asks us to come up with what is the value for K. So it doesn't ask us to find the average, so we can pick any experiment you want to and calculate K. So I picked experiment number 1, and I just substituted in the rate for experiment number 1, and I substituted in the concentrations for the ammonia and the boron trifluoride. So I rearrange it to find K, and I get 3.408 molarity to the -1 seconds to the -1. All right. I know that these are the right units because if it is second order overall, that means it's going to be molarity to the -1, and it's always seconds to the -1. So, two so far, very, very similar. Now we're going to see some changes.